Hi, my name is Matthew Vickers and this is my pneumatic board and my presentation to go along with it. So this is the board. It's actually a dummy board, so it's not actually live. However, it's representative of a live board I worked on during my work experience at Vauxhall Motors, and the board was PLC controlled and it was a Siemens Step 5 PLC. However, this is my presentation. I've got a laminate pack that I usually hand out. However, due to it being on a video, of course, what I'm going to do is pop the sheets up and just video them for about 5 seconds, and then you can pause it and read the sheets if you'd like to. So I'll just start that now. So first of all, this is just an introduction towards it. Okay, secondly, whereas this hasn't actually much use, normally it's just a picture of the board, however obviously I've got the board with me today. Okay, thirdly, we've got some key components that are used. So you've got the control valve, you've got the cylinder rod, you've got the piston head, piston seals, so on and so forth. Now we've got the main sheet which explains everything, so it's got the method of how I made the board, the tools are used, a bit of in-depth information about the PLC and the circuit layout, etc. Usually refer to this sheet as you go, but obviously for the purpose of this video we're not going to, as I'm going to take you through the board. Take that one off. And we've got a drawing, and this is actually what I made the board to. So this is my drawing before I actually done the board. And we'll just get into this final sheet later on at the end. So I'll just pop these to the side and we'll get on with it. So we're going to start off with the cylinder being in the backwards position. Now obviously if it was a live board, the PLC and the proximity switches would be constantly detecting where the cylinder is and firing outputs, etc. But we're just going to start off as in this position. In this position, input 1.0 is made and input 1.1 isn't. Now the proximity switch detects this and sends a signal to the PLC. PLC receives this signal via the input module, and this information is passed to the central processing unit. Now in the central processing unit, this is where the programmer programs the logic. In this case, when an input is made and one isn't, it fires an output. So when input 1.0 is made and input 1.1 isn't, it fires output 4.0. Now output 4.0 means that when air comes through the air regulator and through this tube, it goes from port 1 to port 2. The air then meets a restrictor. Now it doesn't actually go through the restrictor on the forward pass of the air. It instead goes through the check valve, which is a little ball on the seat, and as the air comes up, it lifts the ball off the seat and the air rushes forward. Now when all the air has come through, the ball then returns to the seat. The air then comes through this tube and pushes the cylinder forward as such. Now obviously in this case we haven't got a compressor or anything available to us, so we're just using a foot pump to demonstrate the air coming through. So the cylinder fires forward as such. So now when the air comes through and it pushes the cylinder forward, it's got to exhaust somewhere. So the air then exhausts down this tube and meets another restrictor. Now on the exhaust of the air goes through the restrictor as it cannot go through the check valve. The air then exhausts from port 4 and out of port 3. Now in the position it is now, input 1.1 is made and input 1.0 isn't. Now this information is then sent to the PLC. It's received via the input module, and then the information is passed to the CPU, where the programmer programs when input 1.1 is made and input 1.0 isn't, via output 4.1 this time. So I think it's a 24 volt signal is then sent to the solenoid, and I'll get into more in-depth information about this at the end. However, a spool is shifted across, such that now when air comes through the air regulator and through this tube, the air now goes from port 1 to port 4, instead of previously port 1 to port 2. So when the air goes from port 1 to port 4, it meets a restrictor, again does not go through the restrictor, goes through the check valve instead. Air comes up here, and the cylinder is fired backwards, and the air then exhausts down this tube, meets a restrictor, this time goes through the restrictor as it can't go through the check valve, and the air then exhausts from port 2 to port 3. Now as mentioned, this is a live board, so the spool actually isn't shifting across inside there. However, a way to demonstrate it could be swapping this tube and this tube around at the end, but this would just be tricking the system as it's not actually coming through different ports. However, it would end up sending the cylinder back. Now, as I said, I'm just going to go into more information about this now, as we've actually got an open one available here. So I'll just go into how this actually works. There we go. So as you can see, this is a solenoid, and this is the inside of this 5-port 2-position control valve, like that. Now, when there is no electricity passing through the solenoid, this little shaft in here is held in place with the spring against a little hole just inside there. So it's held like such. Now, in the solenoid, there's actually a copper coil which is wrapped around a soft iron core. Now, this means when the electricity actually comes into the solenoid, an electromagnetic force is generated. Now, this electromagnetic force overcomes the spring and the shaft is pulled inwards towards the solenoid. Now, when this happens, it exposes this little hole. And previously, when air came through the air vents, it could not come into this hole. However, now the hole is exposed, and therefore when air comes in, air can come through this hole and it will push the shaft forward. Not the shaft, sorry, it will push the spool forward. Now, when the spool is pushed, it means that it blocks off specific ports, and that's why the air pathway changes, such that in one case it goes from 1 to 2, and in one case it goes from 1 to 4, and where the air exhausts, etc, etc. And that is how the board works. However, right now, the board has no purpose. So if this was a live board, all that'd be happening is it'd be firing forward and back, and forward and back, and there'd be no real purpose to it. So it got me thinking, well, what could this be used for? Well, this is where I'll refer you to the final sheet here. And firstly, I'm going to put it horizontally, as it represents the board and you can see it better. So I'll just pop it like this. So as you can see, it starts off when the cylinder is in the forward position, and this there is the cylinder, and this is the control valve just there. Now, in this example, we're using a conveyor belt. So let's say you want 20 parts to go to container A and 20 parts to go to container B. Well, first of all, how do you detect parts? How do you know if a part has come through or not? Well, this is where you use PECs, or photoelectric cells. Now, what these PECs do is they shine a beam of light from one to the other. Now, if something gets in the way of that beam of light, it detects something has got in the way and sends a signal to the PLC. Now, what you do in this case, in the PLC, in the CPU, you'd program a counter. So this counter, in this case, is 20. So when 20 signals have been sent, the counter has been made, it fires an output. So in this case, it fires output 4.1. Now, output 4.1 on the board brings the cylinder back. So what I'd do here is it'd bring this cylinder here back, and this diverter plate here, which blocks off a specific route, would pivot about this point here, and as it's brought back, instead of blocking off the pathway to container B, it would block off the pathway to container A. Now again, you'd have another set of PECs for container B, and when 20 parts has passed through, it'll do the same. It'll fire output 4.0, which will fire forward, meaning that parts will go to A, and so on and so forth. Now finally, there was actually a mistake in this diagram. Now, I'd actually laminated all the sheets, but I just explain it rather than laminating even more. So as you can see here, I'll just turn it around now. There are 4 parts very close to one another. However, let's say this part here is the 20th part, and you only wanted 20 parts going through. Well, now you've also got 21, 22 and 23. Now this is obviously a problem, so how could you stop this? Well, to stop this, you'd have a separator earlier up in the conveyor, which would ensure that all parts are equidistant from one another. So let's say this separated all the parts to 2 meters apart, and the distance between the diverter plate and the PECs was 1.5 meters. This has now ensured that no parts get stuck between the diverter plate and the PECs, and it now ensured that there's not an overspill into either container. Now finally, as well, I'll just mention, if you see this PLC logic just here, this is actually the logic of how it all works. So when I was mentioning about the CPU, or the central processing unit, can see when input 1.1 is made and input 1.0 isn't, and the counter, as I mentioned, is at 20, it'd fire output 4.1, which brings it back, or that way. And then at the bottom, when input 1.0 is made and input 1.1 isn't, and the counter of 20 has been made, it'd fire it forward. And that's how it works. I've also got a little bit more information there at the bottom, just background information on how it'd work, if you just want to read that as well. But yeah, this is my pneumatic board and presentation. It's a shame that I've had to do it, obviously, online. However, I'd love to bring it in, but I hope I've made best of the situation, and thank you for watching.